I'm only one, no? Good evening.
Respect, sir. The damped oscillations.
Damped.
Yes, question came from damped oscillation.
I discussed, no?
Yeah, damped oscillation. I know what I'm getting. Sir, few questions came from damped oscillation and forced oscillation.
Okay.
Yes, sir. Which we didn't discuss.
Damped oscillation we discussed, right?
No, sir.
Damping oscillations.
No, sir.
Okay, now we'll discuss what else.
Then now we'll start
Your wish.
revision.
Revision means think I'm searching that only. Tomorrow, what test is there?
Tomorrow, no test.
Tomorrow means
Sunday.
coming.
Sunday.
Full syllabus, mains test.
Advanced.
Advanced. Two papers are there. Paper 1, paper 2.
Sunday on Monday, sir. Huh?
No, Monday only.
Sir, Sunday, sir. Third is Sunday.
Yes. Advance will be held on Sunday only. Correct.
So this Sunday no class, sir.
No class. You have to bring your devices here and you have to write the test here.
Huh?
For you, offline paper I will.
Okay, sir. It will be hard on you, sir. Full person.
It will be
Hard because I joined in January only. So
hard means what, Vishal, in your point of view?
like some chapters.
Hard means something you don't understand. That is hard. If you understand.
Also like fluid mechanics. He joined and only. Like fluid mechanics, you're not taking a school also. So
Then during this discussion, when you are discussing numerical concept, also will explain for you. You will feel comfortable. Now what problem?
School exam.
Which school exam?
Will not come, sir. This tomorrow and after tomorrow will not come, sir.
Oh.
Wednesday and Thursday because school exam.
You attend class and then you prepare, no?
Sir, 12th question.
Okay. Okay.
100 marks.
Yes, I can understand. Okay, very good evening once again, everyone.
Not everyone.
Offline also, online also.
Okay.
Nivasini, Pandey came and jumped. Huh? I think network issue. So on Sunday, you people will have advanced paper 1 is there, paper 2 is there, 2 papers. So what I will do, I will give the revision. Revision in the sense.
He joined the max class. No, he didn't. Yeah, he was in max class. He was, huh?
Jiva.
He is not even joining, so he is not even responding. He messaged him a lot of time.
We went to Delhi, I think. Then who is there? Sai Kiran.
Sir, what about these people, sir?
Vignesh.
Sir, he said he's having his board exams.
Yeah, all are same problem.
Pranav, Sriram.
Government exams.
So they join after May
that
only,
one.
yeah.
No, sir, not this one. Third one. That only.
So they'll join after May only.
Yeah, after June only, after June.
Okay, anyway, many are there in 11th IT. Anyway, I will give revision from first chapter onwards. We will work out.
Sir, we'll do first one.
Sir, we'll do first waves numericals.
Waves,
Yes.
oh, sure.
Sir, we'll do.
Waves,
Waves correct. Okay.
Sir, we'll do
something.
something.
Sir, no, sir, we'll do something. Instead of oscillation,
Instead of
waves and oscillation, we can do anything else. Like apart from thermodynamics and oscillations. Yes, sir.
Sir, then we'll do system of particle rotation.
Yes, sir.
system of particle and rotatory motion. Okay, your wish.
Or we'll do like friction force.
You people will decide one thing and tell to me. I will do.
Yes, so much of yes,
You discuss for 1 minute. Hmm.
Waves, numericals, we'll discuss in open other post other beats.
Discuss, right? You didn't come on Sunday. Saturday also we
Hey, Saturday concept of very number.
No man, Saturday discuss.
Saturday I joined in.
Saturday you joined. Yes, yes.
Last sir completed beats.
Yes, sir completed beats. But in second class, I took numericals.
Saturday only.
Okay.
Okay, anyway, waves will do. What is the matter?
Sir, waves open other.
You decide. You people decide.
Waves open other close other. Beats.
Sir. We'll do. Hey, no man.
Okay, anyway, Jiva
System of particles.
will do. Why? Because they are feeling bored. Why? Because you not came on that day. We will do tomorrow waves.
Yes, sir.
So system
Open
there
or close
by that time they will
Sir, because system of particles from
very important.
4
Yes.
to 5 months we did.
Yeah,
Like
yeah. Very.
it's been a long time.
Yes, we'll do.
Like we'll do
System of particles.
Term 1 we tested.
Okay, students. Anyway, it's a very important chapter. Most of the students feel difficult also. Most difficult chapters are system of particle, rotatory motion,
Charges.
waves, oscillations. Who said that easy?
Sir, in our school, I told in 12th, electrostatic charges will make you feel healthy.
Very easy. That is the easy.
Not like,
Yeah.
not
For your teacher, it may be
but
tough.
the oscillator is not that much.
Okay.
No, sir.
Ah.
I think they say, our teacher said because in our class there are some students who are in some a really bad condition.
Okay.
Like even passing marks are a bit doubtful for them. So for that, sir told if you don't pass, then you have to give supplementary in May. So you lose the first month.
Okay. Anyway, system of particle will do, right? A Planck of mass. Advanced problems only. All advanced problems. Mass m and length capital L is at rest. Is at rest on a smooth surface. On a smooth surface as shown in the figure. As shown in the figure, with a boy of mass small m resting at one end, of it.
Sir, you are muted. Sir, you are muted.
Sorry, I forgot to share the screen. Not either shared, but
Sir, again some person came with your name.
Yeah,
Two.
maybe 2 new students. Okay, no issue. 2 new students joined yesterday. And length capital is at rest on smooth surface. Those who are joined new students, I will explain the concept elaboratedly. Understood? New students and old students again. Okay, elaboratedly only I will explain.
Yes, sir.
As per the data, this is one plank is placed on a smooth surface. This is one plank. Plank means, you know,
Yes, sir.
plank, skating plank, etc.
Sir, this is
It's
also plank only,
it's
right?
yes, plank
No,
only.
sir.
That is plank exercise. Auto joke. Okay, this is the length of the plank. How much? L. What a mass of the plank? Capital M kilogram. And this is the one person standing on the left end. What that person has done?
Walking.
This is the initial status of the man and the plank. What he did? He started walking or crawling or anything. Then he went finally where? As per the data, he went to other end. Say yes or no.
Yes, sir.
So after some time, what will happen?
He'll go there.
He will go there means while he is walking, he is pushing the plank left side. That is action. For every action, there is an equal and opposite reaction on the man. So man is going forward, but plank is going backward. After some time, what will happen? This is the scenario. Say yes or no. So let's say that I will assume the displacement of the plank equal to how many meter? X meter I will assume. How many meter? X meter it gone. Here also the plank displaced left side for X meter. Where the man gone? Man is at the right end. You people respond, what is the displacement of the man?
L minus X.
Shabash, L minus X. Right side, he displaced.
That's all, sir. Problem. Oh, okay. L minus X.
The displacement of the man is in right side direction L minus X.
Okay, sir.
And what is the question here? Displacement of the plank means X value how much in terms of given data. What a given data? Mass of the plank, length of the plank, mass of the man. In these terms you have to answer.
Yes, sir.
What is our system? My most dearest friend, what is our system? Tell me.
Whole thing is man.
System means
Whole thing.
man plus
Plank.
plank. Is there any external force acting on the?
No.
Why? Why no external force? External forces are there, but net external force is zero. Along the x-axis, along the motion, I'll write that point. Along the motion, any forces are acting on the system?
Yes,
I mean external forces.
they'll cancel it. Gravity.
Listen. Along the motion, right? Along the motion means along the x-axis.
No, sir. No.
That is internal force.
Okay.
Friction means
Internal.
man only pushing the plank. That is coming under internal force. Air we neglected. So along motion, external force is how much? Zero only na. Yes or no? So I'll write that point. Along the motion, net external force equal to zero. Who will tell Newton's second law? Net external force, change in momentum of the system equal to how much? Zero. If net external force is zero means the center of mass of this two particles here only na? Here only na? Why? Because if only plank is there, center of mass of the plank is at center. But man is standing left side na? So the center of mass will be near to mass. Right now, this book is there.
In that place, anywhere.
Huh?
In that exact point, will be there.
In that exact point. Here, man also you should treat like a particle.
I explain that example.
See, this book is there na? Where is the center of mass? Here I can balance na? Here one insect is there. One frog or something is there. So where I have to keep my finger
Yeah.
to balance? Here one frog is there now.
Okay, sir.
Understood? So same concept. So if net external force is 0 means, do you think the center of mass change its position?
Yes.
Do you think the center of mass position changes? No, no. Man position changed, Planck position changed, but center of mass displacement is how much?
Zero.
0 only, na?
Yes, sir.
Understood or not understood?
Understood, sir.
So I can write here one statement. Displacement in the delta x. What? Yeah, sure.
Turn off all. No. Yes, man. Still, sunlight is coming, right? Turn off every light.
Or else once open it projector.
Sir, no, sir, it's not coming. Sir, no, sir, it's
coming.
fine.
Now
Now
Max
it's fine.
Plus.
So, sir, we tried in
Not
maths.
coming.
class,
It's
it
going
did not.
again upside. Huh?
Yes, sir.
Okay, no issue. So shall I write one statement? Displacement of the center of mass, how much here?
Zero.
0 I can write, na?
Yes, sir.
Says or no? Means displacement of center of mass 0 means I can also write displacement of the man plus displacement of the Planck is also 0, na?
Yes, sir.
Says or no?
Yes, sir.
Yes, sir.
I mean, displacement is nothing but I
Sir,
can
is it x minus L then? Displacement of Planck. So it's
here
one way.
displacement of the Planck is 0 means I can also write position of the center of mass how much? Someone tell the formula. Mass of the man into position of the man plus mass of the Planck plus position of the Planck divided by mass of the man into mass of the Planck, sorry, plus mass of the Planck.
Is equal to-
This everyone knows, na?
Yes, sir.
Everyone knows this concept. No issue, na? So now this is position of the center of mass means I want displacement. What the meaning of the displacement means? Change in position of the center of mass equal to change in position of the mass, sorry, change in the position of the man and change in position of the Planck must and should be 0 only, na?
Yes, sir.
This term I will send this side. What will happen? 0. So I can write mass of the man into displacement of the man plus mass of the Planck into displacement of the Planck equal to 0. Respond everyone. Mass. What is the mass of the man?
Yeah.
Small m.
Small m.
What displacement of the man?
L minus x.
Very good. Plus or minus? Man is displaced right side means positive side, na?
Yes, sir.
Have to keep plus or minus.
Plus.
Plus then bracket start L minus x. What a mass of the Planck?
Capital S, small m.
Capital M, right? What displacement of the Planck?
X.
Respond.
X.
Think and tell.
Sir, x minus L.
Minus x.
Minus x, right?
Minus x.
Why? Because Planck displaced left side, na? Left
Yes.
means in physics negative x axis, so 0.
Wave equation alone will be possible.
Yes. So m into wave alone positive. Very good. Small m into L minus small m into x minus capital M into x equal to 0. So m into L minus x I can take our target x only, na?
Yes, sir.
So m plus capital M equal to 0. So x if you write as a subject, ml divided by m plus capital M. This is the displacement of the Planck. And one more additional question. Find the displacement of the man. Everyone find the displacement of the man. That is L minus x only, na?
Yes, sir.
Says or no? Put x value here. What you can write L minus x means m into L divided by m plus m. If you simplify,
We'll get
ml by m plus
M plus M,
capital M.
yes,
This is the displacement of the man. I hope everyone understood this concept crystal clearly. Application also.
Still clear.
Clear?
Yes, sir.
Okay. Now one practice problem I will give, you have to do. Length of the Planck, for example, see, velocity of the man with respect to Planck is some 10 meters per second. and find velocity of man. Find velocity of the man. If mass of the man is 60 kilogram and if mass of the plank is 100 kilogram. This is the same concept based question only. What is the MP means? Velocity of the man with respect to plank. This is how much? 10 meters per second. Find the velocity of the man. He is asking. Definitely you will not do. See, shall I write like this?
We have a formula for velocity.
Just now we have written displacement of the man equal to how much? Mass of the plank into length of the plank. Length of the plank shall I write? This is displacement of the man with respect to plank shall I write?
Yes, sir.
With respect to plank, man walked full length L meter only, na? And divide by M plus capital M. On either side, I will divide with time. And here also I will divide with time. So what I can write? Velocity of the man equal to how much? Mass of the plank into velocity of the man with respect to plank divided by mass of the man plus mass of the plank. Substitute everything and tell me the answer. Mass of the plank how much? 100 kg. Velocity of the man with respect to plank is 10.
That second term you are not included.
What?
X is equal to mass of the man into displacement of man plus mass of the plank into displacement of plank.
Not understood. Come again, Vishal.
So if they ask to find for plank means
6.5.
Planck means reverse formula. Reverse formula means velocity of plank equal to how much? Mass into, mass of the man into velocity of the man with respect to plank by M plus capital M.
6.25 meter per second.
Okay. Have to simplify 1000 into 1000 divided by 160, 0 cancels out.
25.4.
25 by 4 means
6.25.
6.25 meters per second. Understood? What concept do we apply? Newton's second law. Sorry, Newton's first law. If net external force acting on zero, displacement of the center of mass of entire system how much? Zero. Okay.
Acting along the motion if it is zero.
Along the motion only.
the opposite to the motion then.
Opposite to
Like,
motion.
it's like
Along the motion or opposite motion, net external force is zero only.
Sir, what if the force is perpendicular?
then external forces and then Newton's law will be
Only in which direction motion is there? In that direction only we have to apply all concepts. Vertical perpendicular to motion, no need of doing any analysis. What is actually x-axis in your max? X-axis means actually that is the axis in which motion takes place in physics. That is x-axis. Y-axis means what? Where the object is in the state of rest in physics is that is y-axis.
okay, sir. One more problem. Using some different concepts. The problem was
He wants to say wrong, right? He said we can do that problem. You
not
different
similar
problem.
I told you one problem, but it's not.
It's a different concept. Then different to this one.
Not
You-
similar.
First you said similar to this.
No, I not. He added that.
Oh, okay.
Okay. Anyway, stop fighting.
Stop listening.
Stop, sir.
Okay, we'll see the
Please 3D.
next question. Figure shows a block of mass capital M, which has a half cylindrical a half cylindrical groove cut in it.
Or it's group cut, sir.
Groove means hole. Groove cut in it. From the top of groove, a small ball of mass, small m, is released. Small m is released. Find the displacement of block. Find the displacement of block when ball reaches bottom of the groove. One diagram also given. Don't feel it is a semicircular groove, it is a cylindrical groove. Mass of this groove, how much? Capital N kilogram. And what is this ball of mass? How many grams? Sorry, and this is the center of this groove, O, and this is the radius, smaller.
So, but now the displacement will take place both in X and Y direction.
Okay. Now, okay, here let us see how the same concept earlier, how we applied over there. Here also, how we are going to apply. See, figure shows a block of mass, how many kilogram? M kilogram, which has half cylindrical groove cut in it. From the top of the groove, a small ball of mass, how many kilogram, is released. Find the displacement of the block when ball reaches the bottom of the groove, how much? After some time, when ball is moving down, at any moment, what will happen? Ball is kicking the groove downside. Normal reaction. No? For every action, there is an equal and opposite reaction. So groove also applying the normal reaction like this. Understood? So, like that, because of this horizontal component of the normal reaction, groove will go left side and ball will go right side. This is a situation when you are jumping out of a vehicle or ship. When you are jumping, unknowingly you are kicking the ship backside. So ship will go backside. Na? Here also, once ball reaches the bottommost point, what will happen after some time? The groove also will reach like this. Please say yes or no.
Yes, sir.
Let's say here also displacement of the groove, how much? Some x meter. Correct or not?
Yes, sir.
Here also displacement of the groove, how much? X meter. Where the ball reached? Wait a second, diagram slightly carefully you have to draw. So now tell me, what is the displacement of the groove? As I told you, x meter. Here also how many meter? Respond, x meter. But what is the displacement of the ball? What is the displacement of the ball? It is r minus x only, na? See this edge from here to here, r, na?
Yes, sir.
And this is displaced x, no? Have you noticed? Then displacement of the ball, how much, my dear students? This only, na? R minus x only, na?
So, but what about Y component? Y
y component displacement of the ball is r meter. Ball come down r meter. Groove is in along x direction only, na Srinidhi? So ball also you have to take x axis.
So what it is also displacing through y axis, right?
Yes, but along y axis, net external forces are there, na?
Yes, sir.
Gravitational force is there. There are not.
Yes, sir.
Normal force also there. There are not. Then net external force is not zero, no? If net external force is not zero means you cannot say displacement of the center of mass is zero.
Yes, sir.
Along y axis, center of mass surely will displace. But along x axis,
Zero.
displacement of the center of mass zero only, na?
Yes, sir.
Understood or not understood?
Understood.
Why? Because along x axis, is there any external forces are there?
No.
No. That's what I am taking only along x axis. Everyone understood or not understood? So what I can write, displacement of the ball, how much? Plus or minus?
Plus.
Only I am doing analysis along x axis.
Plus, sir.
So displacement of the ball is plus bracket start r minus x. And what displacement of the groove? Think and tell. Very good, minus x. Why I am taking only x axis? Respond everyone. Net external force on the system, how much? Surely zero.
Newton's second law. First law.
Then net external force is zero means
Center of mass.
displacement of the center of mass
Zero.
is zero. Understood? So what is the position of the center of mass formula here? We'll tell. Mass of the groove into displacement of the position of the groove plus mass of the ball into position of the, not displacement, position.
The capital and mass.
Later I'll substitute. Mass of the ball divided by mass of the groove plus mass of the ball equal to how much? Zero. This displacement differentiation I will send inside. This I will send right side. So what I can write? Mass of the groove into displacement of the groove plus mass of the ball into displacement of the ball equal to how much here?
Zero.
Zero. What a mass of the groove as per the data? Capital M, right? Groove. Block means groove, na?
Block, okay.
Block is drilled and made it a hole and groove. So displacement of the groove, how much? Minus x. What a mass of the ball?
Smaller.
Small m.
Small m into how much? R minus x equal to 0. And if you simplify, minus m into x plus m into small r minus m into x equal to how much? 0. So x equal to how much here? M into r divided by small m plus capital M. This is the what here? Displacement of the groove. Respond, what is displacement of the ball? R minus x na along x axis. R minus x means what? Capital M into small r divided by capital M plus small m. Directly I can write. If you have doubt, check it. Displacement of the ball is nothing but r minus x only, na? Put this x value here, you will get this. Clear, everyone? Okay, so we'll see a different model. Figure shows two planks. Figure shows two planks inclined to horizontal rough surface. And connected by a string. Find the minimum angle. Find the minimum angle. Find the minimum angle theta for which the system remains in equilibrium. What is the equilibrium? Tell me someone.
Net force is like
Net force is 0.
Net external forces are 0, so that plank should be in the state of rest. Correct or not?
Yes.
You are also equilibrium. Why?
Sitting
On your body, net external force is 0. Correct? Your sitting on the desk is putting normal reaction on your body upside, is nullified by gravitational force. Net external forces are there. Sir, external forces are there, but net external force is 0. That's what you are in the state of rest. Correct or not? That is the concept of equilibrium. Now, what is the question is, if a friction coefficient mu is equal to how much? 0.5. One figure also given. This is the ground. This is one plank. It's making some angle theta. And this is another plank. Also angle theta. And here this is the string. Okay, so both are in the state of rest only, na? Equilibrium means what? Simply, it is in the state of rest. I will take this is plank number 1. I will take this is plank number 2. Draw the free body diagram of plank number 1. Plank number 1. So tell me how many forces are acting on the plank number 1? Respond. Plank is only your system. So for plank, how many external agents are there? This rope is one external agent. Ground is external agent. Earth is external agent. Understood or not understood? Understood, everyone?
Yes, sir.
So rope is always pulling or pushing? Rope always will pull with what force? Let's say tension T. Correct? Ground always will give the normal reaction. Say yes or no. That is capital N. And then earth also always attracting upside, na? Sorry, downside, no? Earth is also pulling downside, na?
Yes, sir.
That is how much? M into G. Then it is in equilibrium means rope is pulling right side means friction pushes left side only, na? Correct or not? So the friction will push left side. So along y-axis, how many forces are there? Only 2 forces. Normal force must and should be nullified by mg. And left side, how many forces are there? Tension equal to how much? Compulsory friction. Who will tell friction formula? Mu into n. Mu into normal force. Normal force equal to nullified by mg only, na? So substitute nicely here. Tension equal to how much? Mu into m into g. but we have to find the angle theta for which system remains equilibrium. Correct?
Yes, sir.
So about this center, about the center, it is also not rotating. Means rotational equilibrium also is there. No translatory motion. So translatory equilibrium is there. No rotation also, na? So rotational equilibrium also there. Translatory equilibrium means what? Net external force is 0. Rotational equilibrium means what? Net external torque must and should be 0.
Yes, sir.
Yes, sir.
For translatory motion, how external force is helpful? For rotational motion,
External torque.
torque is playing the role of force in rotational motion.
Yes, sir.
So I can also write for finding theta, I will take this center of mass O. About center of mass O, net torque must be 0 only, na? About O. Any point you can take. If you take this point A, point B, center of mass, anywhere you can apply the equilibrium concept, rotational equilibrium. Tell me about O, how many forces are creating clockwise torque? Tension is trying to rotate the rod plank clockwise. Normal reaction trying to rotate it anti-clockwise. And friction is trying to rotate clockwise. If you have doubt, check it. The plank is like this, na? Rope is pulling like this. So it is trying to rotate clockwise only. Friction is rotating clockwise only. Say yes or no? So I can write here sum of the clockwise torques nullified by sum of the anti-clockwise torque. Who will tell torque formula?
I omega.
Perpendicular distance into force. This is only perpendicular distance, na? This is perpendicular. That is also correct, but here will not work. Understood? What a perpendicular distance here? Tell me. Length I will take L by 2. L by 2 and this is theta. So this is L by 2 sin theta only, na? This red color one.
Yes, sir.
Again, I will modify this. I mean, somewhat magnified view I will draw. This is the plank only, no? The center of mass. Tension, what a perpendicular force, students? Perpendicular distance. This angle theta means this perpendicular distance how much? L by 2 sin theta only, na?
Yes, sir.
So I can write clockwise torque due to tension how much? Force into perpendicular distance. What a perpendicular distance? L by 2 into sin theta. Understood? What is the anti-clockwise torque? Normal force is providing anti-clockwise torque, na? Torque formula. Again,
Even MG is providing anti-clockwise.
mg is passing through center, no? So it won't provide any torque.
Yes, sir.
Understood? So what a torque due to normal force? Normal force into perpendicular distance. This is a normal force, na?
Yes, sir.
So this is a perpendicular distance. See this one. How much this is? This is L by 2 means this is theta means this is L by 2 cosine theta only, na?
Yes, sir.
This value L by 2 cosine theta only, na?
Yes, sir.
So I can write L by 2 cosine of theta. Next, friction is also there. This is a friction, this is a plank, this is a center of mass, this is a friction, correct or not? Says or no? This is a friction, correct or not? What is the friction is trying to rotate clockwise only. So what a perpendicular distance respond?
L by 2 sin theta.
This is L by 2 means this is theta means this is L by 2
sin theta.
sin theta, very good. So
Sir,
Left side, sir.
Sir, left side on the right side.
Clockwise. Yes, sir.
clockwise means very good, left side will come. So friction into how much? Perpendicular distance how much, friend? L by 2 sin of theta. Friction formula how much? Mu into n. N value mg only, na? So mg into L by 2 into sin of theta plus t into L by 2 into sin of theta is equal to n into L by 2 into cosine of theta. Everywhere L by 2, L by 2, L by 2 cancelled out. Mu value how much is given as per the data? 0.5. Yes or no? And mg into sine of theta
Sir,
plus
N and mg gets
tension
cancelled.
equal to how much as per the data? Mu mg only, na?
Sir, N and mg gets cancelled.
Yeah. Mu mg into sine theta equal to normal force equal to how much? Mg into cosine of theta. mg cancels out. So 0.5 sine of theta plus mu also here again 0.5 sine of theta equal to how much? Cosine of theta. 0.5 how much, right? Sine theta equal to cosine of theta. So theta equal to how much? 45 degree. When both trigonometric ratios are equal, if theta equal to 45. I hope everyone understood. What a concept here? Rotational equilibrium concept. Rotational equilibrium concept and a translatory equilibrium concept. Okay, students. Now, in the next session, some more things we'll discuss. Anyway, new students, please don't worry. Why? Because these concepts you not attended, it is not your mistake if you feel difficult in understanding. Once 12th standard started, you will understand everything. Okay. Thank you, students. You can leave now. Take 5 minutes break. Right. Thank you.